Is this like an derivative?
I got time for two of them. Anybody want?
Whichever one you think are the most difficult.
Oh, I'm supposed to choose the most difficult one?
Yeah, I'm sure a little bit that would
Those are the two most difficult ones left. Okay.
And then just cross off top and bottom.
This one up here is the one that I didn't. I'm not going to do, but we'll give you the hint. Some of you got it already over here. You look at the trig and it's got X in it, and then it's got stuff everywhere, more complicated than you've seen so far. Except one key recognition. I see a 1 minus cosine squared, which should be a Pythagorean identity. Bing. That's really sine squared. So your sine squareds cancel, and this all is just the integral of the cosine of x. Just the integral of cosine of x. Now this one here, a couple things that you should recognize, and there's confusion in it. I see the 2x here. Like this one over here, I had a 2x. First shot was putting u equals 2x in on it. Here, you've got a fourth and a squared as well. Well, if you rewrite the fourth like you're supposed to, I think it might jump out as a little easier than letting u equal 2x. Because if I let the u equal 2x, I'm not going to get one of my 6 trig functions. Remember what the derivative of the tangent is. It's secant squared. Secant squareds and cosecant squareds usually are parts of your du's. Not always, but usually. At least for now they are. So now, if I let u equal my tangent of 2x, everything should work out pretty nice. That's the derivative of the outside times the derivative of the inside with the dx. Derivative of the outside, derivative of the inside. I go do my switching. That's just u to the fourth. And now I need a 2 and a 1/2. And that all gets sucked into the du if I let u equal the tangent of 2x. So the higher power kind of trumps the inside trig. And you can finish it from there in the interest of time before I'm going to get beat.
Making the square root move to the top.
Okay, I can move this guy to the top, and also what kind of jumps out?
There.
If I let my u equals here, what also, I'm going to have to find something, because my du is just dx. So this is probably a u equals x equals, when that same kind of stuff is there. So if I let u equals x plus 1, du is dx. When I go do my switching, that'll be u to the negative 1/2. But I've got to get the x minus 1 switched. So x is actually u minus 1, right? So then I go switch here, that's u minus 1 minus 1 du, which is really u minus 2. Then what do I have to do? Distribute that all back in, and so I've got u to the 1/2 minus 2u to the negative 1/2 du. And I'm going to get beeped so you guys can finish that up from there, I'm sure. Look at these, any of the other stuff, you got questions on them, we'll put solutions. Yes, sir?
How do you put u minus 1 and 2
U is, x is u minus 1. So that I put u minus 1 there and I still have the minus 1.
Alright.